Today's lesson is on function notation, and here we have a picture that I call a little function machine. And what it does is you'll take input values, in other words, values of x, so let's say x equals 2, and you will plug them into a function, let's say 3x plus 4, but it's fancy notation, so I'm going to put this little f of x in front here. And what you do is really all you're doing is plugging in for x. And then you'll get your output, which is f of x, which is the same thing as y. 3 times 2 is 6, and 6 plus 4 is 10. Input values into the function to get your output values. So here are the two words, input and output, and I just want to do a quick review on what other vocab words correspond to input and which words correspond to output. Input represents your x values, which is also your domain, and then what we're adding is this function notation, and the number inside parentheses is your x value or your input. And your output represents your y values or your range. And in this case, if you plug 2 in as your input, whatever that equals is your output or your y value. Here I have two examples that are actually saying the exact same thing. We're familiar with this bottom example, y equals 3x plus 4, and then x equals 2. And we would know that we can then plug in 2 for x and solve for y, and say that y equals 3 times 2 plus 4, which is 10. This top example is doing the same thing, it's just in function notation. It's fancy notation. Instead of y, we write f of x, which is saying the function of x, of the variable x. And then instead of saying that just x equals 2, we say f of 2, is because we're replacing the x of f of x with the number 2. It's our way of saying that x equals 2. So if we plug in 2 for x, it's the same thing, except instead of saying y equals 10, we're saying that the function where x is 2 is equal to 10. So that's what we will be doing. We're going to do 4 examples now together using this notation. Alright, first example. F of x equals 5x minus 3. That is our function. And we want to evaluate f of 2. All that means is that x equals 2. So 5 times 2 minus 3. 5 times 2 is 10. And 10 minus 3 is 7. So f of 2 equals 7. Okay, next example. F of x equals 10 minus 2x, and we're solving for f of 5, which just means solve for x equals 5. So we have 10 minus 2 times 5. Don't forget order of operations. You don't just go left to right, we have to multiply before we subtract. So 2 times 5 is 10, so we have 10 minus 10, and that equals 0. So f of 5 equals 0. And the 0 that we just solved for, remember, that is your y value. So if you were to write a point, a coordinate point, you would have 5 is your x value, is your input, and 0 is your y value, your output. Alright, f of x equals 1/3 x plus 12. Find f of 9. So 1/3 times 9 plus 12. When you multiply an integer times a fraction multiplied to the numerator, 9 times 1, So we have 9 over 3 plus 12. 9 divided by 3 is 3, and 3 plus 12 is 15. So f of 9 equals 15, and always go back and think which number represents your x and which one represents your y. 9 is the input, 15 is the output. So we have x and then y. Okay, last example using this basic function notation. We want to find f of 2/5 when f of x equals 2 times x plus 1/5. So we have 2 times 2/5 plus 1/5. So 2 times 2/5 multiplied to the numerator, 2 times 2. So that becomes 4/5 plus 1/5. We have common denominator, so we can just add the numerators to get 5/5, which is just 1. So f of 2/5 is 1, which means 2/5 is my x value, my input, and 1 is my y value, my output. Here I have a function table, which is the same thing as an xy table, because remember, f of x is just fancy notation for the variable y. Let's say my function is f of x equals 3x minus 1. And then it says choose values for x to make a function table for each function. And I am perfectly fine if, for now, you choose the x values of 0, 1, 2, and 3 every time. So those are always your x values. The middle column is where you show your work, and then the last column is what you get as your answer for the output. So let's plug in 0 into our function. So that is saying 3 times 0 minus 1. And then when we plug in 1, it'll be 3 times 1 minus 1. 3 times 2 minus 1, and 3 times 3 minus 1. So the only thing changing is the number that we're plugging in for x. So now, what do we get as our output? 3 times 0 is 0 minus 1, negative 1. 3 times 1 is 3, minus 1 is 2. And 3 times 2 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 is 8. So there's my function table. And then I just want you to keep referring back to this. Always know that this would represent the point 0, negative 1, and the point 1, 2, and the point 2, 5, and the point 3, 8. Now, after you fill out the function table, it also says to state the domain and the range of the function. The domain is the set of x values, which we have as 0, 1, 2, and 3. And then the range is a set of y values, which we have as negative 1, 2, 5, and 8. Alright, last example. We're going to use function notation in reference to a story problem. It says a scrapbook store is selling rubber stamps for $4.95 each. So each stamp cost $4.95. The total sales, f of n, is a function of the number of rubber stamps, n, sold. So we're using the variable n instead of the variable x. Write a function to represent the total sales. So we have to do that first, and then determine the total sales for 5 stamps, and then we do that. So remember, we're not just getting a final number, we're practicing writing out a function rule. So usually it's f of x. However, they're telling us that the variable in this case is going to be n. So the function of the variable n is equal to $4.95 per stamp sold. And what this tells you is that n represents stamps and f of n represents money. So here we have written a function to represent the total sales. Now it says determine the total sales for 5 stamps. So n represents stamps, so we're plugging in 5 for n. So instead of f of n, we're solving for f of 5 equals $4.95 times 5. So you should get that f of 5 is equal to $24.75. So they're saying that 5 stamps will give you a total of $24.75, input and output. So there's your full lesson on function notation. It's a concept that we kind of already understand, we're just writing it in a different notation. So good luck with the lesson.